Good morning, everyone. My name is Andrew Fisher. This is Ron Powell, Mark Heller, Nick White, Titus Longu, and Robert Marshall. Our project is the world's first active surveillance as a service solution.
There is an active need for security worldwide, such as the event that happened in Paris.
We want to capture more suspects, less repeated offenders, less campus crime, and safer campus for students and faculty.
Our current design objectives involve the following. We want to maximize accurate detection of suspects and trackees. We want to maximize usability of the service for law enforcement and potential customers. We want to maximize utility and relevance for our customers. We want to minimize false readings of trackees, minimize network usage during data collection and tracking, and we want to minimize interaction and setup of the system.
So our technical approach will be broken down into 4 parts: unmet needs, the design concepts, and finally our selected design and the technical specifications for that design. We'll be focusing first on the unmet needs.
As far as the unmet needs, we're going to be focusing on real-time analysis, multiple camera tracking, ground level analysis, and uninterrupted surveillance.
So we went through a few iterations with our design concepts, and we created this graph here, which is a plot of efficiency, effectiveness, and the complexity of a project. So optimally, you want a project that is a small dot in the top right corner of the graph. This would have low complexity, high efficiency, and high effectiveness. As everybody knows, as a project becomes more efficient and effective, sometimes it grows in complexity. So this first project here, although not very complex, which is good, has little efficiency and little effectiveness. Number 2 was a second iteration that we had that was a little bit better, although it's not quite what we're looking for this project. Designs 3 and 4 are more what we're looking for, with 4 being a full-featured web application and 3 being a desktop application. We decided to go with 3 because the slightly lower complexity for this project would allow us to come in just in time, where number 4 would have us put a little bit past July. Also for this to select a design, in order to select a design, it had to meet 4 criteria. This application needs to be scalable, it needs to be cost effective, it needs to be secure, and it has to be flexible. With these 4 in mind, what we were able to do is take several of our designs, pass them through a filter until we got a feasible design. The technical specifications for that design fall into 3 major categories, the first of which is the algorithm for that design. The algorithm concerns itself with detection and tracking. The second area of the specifications is the actual system architecture, which is going to be a layered design. It needs to be scalable and it has to be effective. Third, last but not least, is the distribution and maintenance. This software needs to be delivered to customers efficiently, and it needs to have updates and user support at all times.
So our entire algorithm will be based on a currently available open source computer vision library, which is able to track and detect motion, objects, and colors and shapes. And we will use this then to have our system make intelligent decisions. The open source library that we'll be using is called OpenCV, and like I said, it can detect humans most importantly, and then different colors, different shapes, different objects. It's a bunch of C++ functions that can do this, and then mGlueCV is a .NET wrapper which wraps the C++ functions into C# functions, which makes it easier for us to work with. And now you'll be able to see an example of us tracking multiple humans in real time. The tracking and analysis is being done while the video is being recorded. So the main novelty of our project is to be able to track the same person from camera to camera and identify it as the same person. So to do this, we have 4 markers or identifiers that we're going to use. First is the RGB color pattern based on the person's clothing, skin tone, and hair color. Next is the size of the person, most importantly their height, and then things such as the size of their head, torso, arms, and legs. Next is the person's motion, so their speed of travel and the direction of travel, and then gait and their different patterns of walking. And now we will show an example of us tracking a person. Again, this analysis is being done in real time as the video is being recorded. As you can see, even though the lighting is bad and the face is not always fully facing the camera, it can still detect them. So once we identify a person and tag these features to their ID, we'll be able to match them from camera to camera and know it's the same person, such that when a crime is committed, we can begin active suspect tracking for law enforcement.
So how are we going to do this? Our system architecture is a layered design. We're going to have different layers, each that do not need to concern themselves with the implementation details of the layer directly below them or directly above them. So the first layer is our presentation layer. This presentation layer can be any number of things. It can be a web application, a desktop application, or even a mobile application. All it has to concern itself with is updating its own user interface, which might look something like this. Where in the bottom left, you would have a video. In the bottom right, a campus map. And this would be for law enforcement use, where they would be able to see at a glance all of these different attributes. At the top, they'd be able to select a zone or area of concern. They'd be able to select an active chase, all sorts of data that they would be able to report on within the app. But the presentation layer would make this possible without having to concern itself with the implementation details of the algorithm. The algorithm itself is located in the business logic layer. This is an independent layer where the logic is going to happen. This is where the data is going to be pulled in and processed. It's going to be a controller for the data. It's going to hold the algorithm, like I said, and it's going to hold all the data access logic. Third layer is our database layer, a pretty important layer. It's also independent. It doesn't need to know how it's being accessed. All it needs to do is maximize the efficiency that it stores in which it stores its data. So it's optimized for capacity, it's optimized for speed, and because we're using a distributed database, its capacity of that database is going to be near limitless. Seen here is an example of an entity relationship diagram. The important part of this slide isn't the actual diagram itself, it's that we're using a relational model. This is going to give us superior speed to if we were to use a non-relational model, a NoSQL database, for example. And lastly, important to a lot of IT operations is the big data analytics that can come from this. We're going to have a lot of operational databases, little clusters of SQL Server databases that can be loaded into a data warehouse. Once this data is loaded and stored historically, it can be reported over by a Hadoop cluster. We can run exploratory analytics on it. And this would all be done in the database layer. And a sample of what that might look like would look something like this, where you would be able to generate with ease a heat map of where crimes are occurring in the city, something that can't currently be done just because of the granularity of the reports that exist now.
So our project management can be broken down into three categories: the deliverables, the budgets, the communication and planning for our project. So the deliverables are going to consist, there's first, the WPF application, which is going to be what the user sees. The logic library is where the actual tracking is going to be happening. The operational database, which is where you'll have the ability to persist and make intelligent decisions using that data. And the data warehouse, where you will be able to perform exploratory analysis on your historical data.
So our budget for a project has three main portions. First of all, processing, then the actual cameras and software licenses. Due to the resources we currently have both on and off campus, right now the values are all zero.
In order to organize our communication and planning, we're using Visual Studio Online. The utilization of Visual Studio Online allows us to access our current version of our code from the repository. We can download the code and then eventually update the code and push it to the repository so our members can download it and then update it. And then we can communicate through Visual Studio Online and then assign tasks to each other. And then here is the user interface of Visual Studio Online, where we can assign tasks to each other and access the code.
So as of 2013, the video surveillance market had estimated net worth of $14 billion. Of that market is a small subsection called the Video Surveillance as a Service market, or VSAAS. That has an estimated net worth of about $2 billion. The VSAAS is about the closest approximation to what our project would fit into. It is important to note, though, that our project is different than it, because as of right now, that would be a passive system. As of our system is an active system, where we will actively process data as it comes in to track people and to update a database. In 2020, the video surveillance market is estimated to have a net worth of $48 billion, and the video surveillance as a service market is estimated to be $6.28 billion. That's a 400% growth in a little under 5 years. So, actively around the world, there are about 100 million cameras in use. If we estimate implementing this system across 10 million of those cameras, and we charge $10 per camera for processing and maintenance costs, we can estimate $100 million per month, or $1.2 billion per year.
So here's a very simple breakdown of our timeline. First, our design phase, which is completely done, which is where we performed architecture, created architecture diagrams and the process flow diagrams. What we are working on currently and will continue to work on over winter break and during the spring is the development, which is where we develop the logic and the algorithm, and also the system architecture. Here is a more detailed breakdown of what we will be doing with the Gantt chart. As you can see, all of the research is done, the development is currently what we're working on.
Yes, we'd like to field any questions you may have regarding the project.
You lost me on the budget slide. Help me understand that.
Sure. So with the resources that we have available at the school, open source resources, there won't be any licenses. Everything we're doing is open source and free, so we're not going to need to license any software. The cloud processing, there's lots of free online cloud providers that we can use to get started. So our initial budget for setting up this project is zero. We don't have to buy anything physical, and we certainly don't have to buy any software or any server time, so we can set that all up on our own.
And what exactly are you hoping to deliver at the end of this project?
We're going to deliver a WPF application, which will be the front end, which is going to be able to be implemented on any Windows system. In addition to that, we're going to have the actual logic that's going to hook up to that application for pulling in all the streams and processing them. We're going to have our operational database, so we're going to be able to persist all of the data that's coming in and all the decisions that are made. And lastly, we're going to implement a light version of a data warehouse, where we'll be able to offload that data for both performance reasons and reporting.
It wasn't clear to me, what spurred you on, what motivated you to pursue this project?
Just all the events that have been happening recently, cities aren't that safe. I mean, obviously just the event in Paris, there is clearly a need for more active surveillance. Right now, as we've said, there are plenty of companies that offer the ability to put a webcam in your business, in your home, and view that on your tablet. That's great, but that means someone has to be watching that all the time, and people get tired. We need something that can go across campus and track people on its own, and when a crime is committed, automatically report on it and tell law enforcement, this is where it happened, and this is where the criminal's going. So we get texts all the time about crimes happening at CSU, mostly robberies. Those people are almost never caught. With this system, it will track them, even though the cops arrive 5 minutes later, which it makes sense that it will take them 5 minutes to get there. They'll know at that time that the criminal is 5 blocks away to the left.
So in addition to what he said, the current model is when a crime happens, the police are notified via some stimuli, whether that's the Viking app, whether that's a phone call, or they just hear from somebody else, another phone call that somebody got robbed. When that happens, they arrive at the location where the crime happened. There's no way for them to know where the person who committed that crime went. On the other hand, with this system, they would be able to see everybody in that area when that stimuli was generated, where they went, where are they currently, and they would be able to quickly iterate through each person that was in that area, see who is the person who's a suspect, tag them using the app, and that person would then be tagged on the map for all law enforcement in that area to see. So as that person goes to flee throughout the city, they would be tracked from place to place, picked up from camera to camera, and they'd be tracked in real time. Yes, sir.
Nice presentation you got today, guys. Good job. I actually have a comment and a question. The comment is very large scope. It is a very, very ambitious project. So the associated comment is, I would recommend a hierarchy of deliverables. A key deliverable would be one. You could pick any, one deliverable, and then the others can cascade from that so that you're sure that you have a deliverable when you finish. And the second, if you could talk a little bit about how you manage across such a large group. There's a big team there, and I'm sure that, I know you talked about the timeline, but what about leadership and communication?
Well, we did mention that in the slide. We're using a tool called Visual Studio Online, which is a code repository. And on top of being a code repository, it also has a spot for a chat and also for updating a timeline almost. That way you can assign tasks to other people in the group, and it gives them a due date, which gives a little more accountability, I'd say, for getting these sections of the project done. And it's a good way to split up because then everyone can see what everyone else is doing, because everyone is alerted when someone updates the code. Everyone's alerted when a section of the project is done. And then we can use that to communicate between each other to figure out where someone needs help or like, you know, who finishes early so they can jump onto another section. And that's all hosted through Visual Studio Online.
So in addition to what Mark said, the tool we're using is for agile development. So we broke what we're going to do into several iterations, with the first iteration being our minimum viable product, which is just a working application, doesn't have all the bells and whistles, and by the end we're hoping to have all the bells and whistles. So with this tool, what we can do is we can plan the tasks that we want to complete for each iteration. And we broke the iterations into 2 weeks, 2-week sprints, and the tool automatically creates burn down charts of, you know, who's, like Mark said, who's lagging behind, who's really excelling, and it allows us to keep a pretty good audit record of what exactly everybody's doing.